Welcome to our talk on GAN-based creature synthesis. My name is Vaibhav Vavilala, and I'm a PhD student at the University of Illinois at Urbana-Champaign, advised by David Forsyth. Stalgian representations have successfully modeled a number of image domains. In many cases, the synthesized quality is extremely strong, as measured by image quality metrics such as FID, and recently controls have been developed by analyzing the principal components of the latent space. In this project, we collect and attempt to model a new dataset, the Yu-Gi-Oh! Card Art dataset. This dataset is extremely diverse in terms of style and content. For this work, we choose to model the monsters only, for which there are about 7,000 images. As you can see side by side, card art is quite different in style, content, and overall diversity than many previous datasets. To clean up the dataset, we first tried instance selection, a recent technique to remove sparse regions of the data manifold. But for numerous embeddings we tried, we did not get results that we thought should be pruned, as shown in the top left. And instance selection did not detect samples we thought should be pruned, shown in the bottom left. So we ended up manually cleaning up samples, ending up with around 6,800. To improve the quality, we applied JPEG denoising and super resolution to the images, increasing the resolution to 512. Here we show the StyleGAN-2 architecture. It's built up from many convolutional layers of increasing resolution. One key feature is that each layer takes two inputs, a latent code and a noise tensor. As we show, having two inputs per layer could become a problem if the latent loses some control of the synthesis to the noise. When training a default StyleGAN-2, we observed that changing the noise significantly changed the identity of the creature, as shown in the top row. We also attempted to edit the generated images by using latent PCA. We found it hard to change the identity with this technique, oftentimes only observing changes in style. The implication is that much of the control over creature identity is governed by the noise buffers instead of the latent. This is undesired since GAN control primarily operates upon the latent. To address this problem, we propose a simple workaround to the noise-latent trade-off issue, simply setting the coarse-scale noise parameters to 0 during training and inference. Since changes in identity are primarily governed by coarse-scale layers, by setting the noise to 0, the latent will retain complete identity control. In the figure, the top row shows 3 noise instances of the same latent using the default network, showing the undesired changes in creature identity. In the bottom row, we show 3 instances of noise for our modified approach, which maintains consistent identity. Our quantitative evaluation shows that our procedure produces better models for card art as measured by FID, and by training networks with and without noise buffers, we found that noise is important for card art synthesis. Using PCA, we can examine how perturbations to the latent change the synthesized image. The default network shows that changes to the latent result in changes in style, as opposed to content, which can be undesired. Using our modified training procedure, we can see that changes to the latent result in significant changes to creature identity. Thus, the default network is very difficult to use in a GAN editing workflow for artists, whereas with our technique, such a use case becomes possible. Here we show that key GAN editing paradigms like projection and style mixing are preserved with our technique. The first column shows 4 images from the training set. The second column shows the result of projecting those images into the latent space. The remaining columns show the result of style mixing the high-level latents from the first row, controlling style, with the low-level latents from the second column, controlling content. In the table up top, we show key parameters associated with deploying a trained StyleGAN-2 into a production workflow. On the bottom, we show the result of sequentially editing an image starting from a random latent. Identity changes to the creature would be much harder with previous techniques. Here's an interactive demo editing a deployed StyleGAN trained on card art, showing features like PCA perturbation, style mixing, changing the random seed, and more. We note that the noise-latent trade-off issue we observed here did not manifest in many of the benchmark datasets, such as faces, cars, and animals, which have dense data manifolds, but they did occur in the Breckenhead histopathological dataset that has only 162 samples. We think the noise-latent issue is related to both the number of samples and their diversity, with our technique appearing to be a promising workaround. Finally, here's a curated set of images we generated, enabled by our interface. Thank you for listening.